We want to look at this example here. In the previous example where the ro-ro deck was flooded, we worked out the free surface moments and we divided them by the displacement of the vessel to get a correction. There is another way we can solve the problem, and this is where we introduce the free surface moments into our kg table, which gives us a fluid kg and a fluid GM. It gives us exactly the same answer, but just shows another way of doing it. So here we're floating at an even keel draft of 6.72, GM 0.5, with a deck 30 metres long, 20 metres wide, flooded with fresh water to a depth of 0.8. Height of our deck is 9. We need to calculate the GM. Well, the weight of the water is simply 20 times 30 times 0.8 times 1, because of course freshwater's density is 1, 480 tonnes. The centre of gravity, the kg of the water, has got to be the height of the deck, 9, plus half the depth of the water. 9 plus half 0.8, 9.4. The first value we always put in this table, of course, is our displacement and our initial kg. Well, in this problem we're not given either. However, we're given our even keel draft of 6.72 in salt water. We go into the tables, look up 6.72 and get the displacement, 13,932. Also get the km, 8.37, because of course we know that kg will equal km minus gm. 8.37 from the tables minus 0.5, so we've got our kg 7.87. Displacement kg, 480 tonnes, 9.4. Now let's introduce the free surface moments that we've calculated here. lb cubed over 12 times density, 30 times 20 cubed over 12, 20,000 tonne meters. What you have to remember here is we must add the free surface moments. Always add them. The reason we add them, it increases the number of moments. When we divide that by our displacement, final displacement, it must increase the kg of the vessel. Because we've increased the kg, when we subtract it from the km, it gives us a reduced GM value. So the fluid kg 9.31, from the tables, interpolate to get our km at 8.35 with the final displacement, and gives us a fluid GM of minus 0.96. So one point to note here, at 6.72 the km was 8.37. We then had to go in with our displacement of 14,412 now, because we'd introduced this fresh water, and at 14,412 the km is 8.35. So we've used two different values of km there, and you can see why we've had to do that. So that's another way of solving a problem when we have free surface. All we need to do is add them into the table. In some ways I think that's a better method, because with the previous method with the ro-ro vessel, when you have to divide the moments by the displacement, students could easily make a mistake and divide the moments by the initial displacement rather than the displacement having loaded cargo or had the water in the tank. This way, of course, we're just putting the values straight into the table to give us a fluid kg, and I think possibly it's a more fail-safe method to avoid making a mistake.